Dear my students, let us proceed again. Here we are going to look about sound and sound waves. Well, we're going to look how sound waves differ among the sound themselves. In the last few seconds, we discussed that sound waves need the media for it to move from one point to another. But sound waves travel very fast in solid than in gaseous or liquid. Why? Because the solid particles are very close to each other as compared to gaseous particle. Hence, in solid, the sound wave transmissions is easier as compared to liquid or gases. Due to this concept, we have different phenomena. Which support that sound waves travel very fast in solids than in gaseous. But again, let us now look how sound waves travel in the solid themselves. Let us assume we have metal and we have wood. I think you know if a metal and a wood are disturbed, sound waves travel very fast in metal than in what? Wood. Why so? This is because vibrations of particles is high in metal than in what? In wood. Therefore, although metal and woods are all solid, but again sound wave transmission differs. Why? Because of where the particle vibration is faster in metals. Therefore, in metal, particle vibration is faster as compared to wood, where particle vibration is what? Is slow. And it is due to this reason bells are always made with metal and not with wood. Therefore, due to this, we can also comment that in sound travel very fast. But again, among the sound themselves, sound transmission differs. It depends on which salt particle vibrates more. For example, metal particle vibrates more than any wood. Now, after that point, we have another interesting idea or concept. This is concerning about a vacuum and sound wave. Vacuum and sound wave. I think you know what is a vacuum. A vacuum is an area which is empty. Vacuum means no atmosphere. No atmosphere. If there is no atmosphere, means no particles. Now the question is, could sound wave travel through vacuum? Could sound wave travel through the area where there is no particles? We're going to prove this if at all it is correct or it is not correct. But for the last cases, we have seen that sound waves travel in all medias. That means solid, liquid, and gaseous. But what about vacuum? This is an interesting story. Now we have an experiment which will verify that if the sound waves will travel through vacuum or will not travel through vacuum. Here is the apparatus. In this apparatus, we have a gas jar on which into it we have a circuit which consists of electric bell and a source of current or EMF and the switch. But also we have the air seal which can be a rubber which can prevent air either to go out or to come in. By the beginning, let us assume the air seal was sealed when there is air around. There is air here. That means is in, that means the gesture is not evacuated. That means air is not removed from the gesture. What's happened? When the switch K was tapped in or was closed, the person around this circuit heard the sound, the ringing of a gong of electric bell. Remember what is electric bell? Something which produces sound. Therefore, they hear the sound from electric bell. Do you know why they hear the sound from electric bell? Yes, because this media was consist of what? Air. The media was consist of what? Air. Air transmit sound waves. Therefore, that's why they hear they heard the electric bell sound. After they removed this air by using vacuum pump, they evacuated the gesture. Now here there is no air. That means this is now becoming vacuum. Under this experiment, now this is vacuum. The air was removed away, and the air sealed was sealed tightly to make sure that there is no air coming in to the gesture. Do you know what's happened after the switch K was closed? Yes, this is what happened. No sound was heard from the electric bell, although the gong was seen as ringing. The gong was ringing, but the electric bell, but the sound from electric bell did not be heard by person who was surrounding the gesture. Do you know why? This is because vacuum cannot transmit sound wave. Sound wave cannot be transmitted by vacuum. That's why, although the gong was ringing, but still sound waves of electric bell did not be heard. Therefore, what can we conclude from this experiment? From this experiment, we conclude that sound waves needs medium. That means needs the particles for it to transfer. Sound wave do not transfer through vacuum. And mind you, you'll be asked to explain briefly the experiment which show that sound wave that does not transfer through vacuum. This is the experiment. You should start by drawing this diagram. From there, you start writing what I have said. This is the experiment which show that the sound wave do not propagate or do not move through what? Through vacuum. This is the experiment. Now, this phenomena, conclusion is that one. That means sound needs medium. If there is no medium, no sound waves will be transferred. Now, due to this phenomena, or due to this experiment, in our daily life, we observe different phenomena. One of the phenomena which we always observe in our daily life concerning about this part is two astronauts. These are the person which goes to the moon. Two astronauts, they cannot hear each other. They can not hear each other when they are at the moon, even though they are very close to each other. They are very close to each other. Very close to each other. Do you know why the astronauts cannot hear each other even though they are very close to each other at the moon? Yes, the reason is very simple. Sound wave needs media. To the moon, there is no atmosphere. There is no particles. To the moon is vacuum. Therefore, they cannot hear each other because sound waves do not transfer in a vacuum. sound wave needs a medium. But if they want to hear each other, they need to convert sound wave to radio waves. Radio waves is electromagnetic waves which can transfer through what? Vacuum. Therefore, for them to hear to each other, they always wear a special device which convert the sound wave to radio wave. If the sound wave will not be converted to sound waves, in which the sound wave can transfer through vacuum, they cannot hear each other, because sound wave itself cannot transfer through what? Through vacuum. But again, another phenomena which we always observe is sometimes out of the Earth or to the moon or to the other planets, some of the physical activity, or we can say explosions. Example 2, explosions on other planets are not heard. You cannot hear explosion on other planet when we are on the Earth. On Earth. Do you know why? Because there on these planets there is vacuum. Hence, no sound wave can transfer in vacuum. No sound wave can transfer in vacuum. Therefore, my friends, this is the end of today's presentations. See you in the next lesson. Bye.